Alright guys, this video is about 6.2, which is going to be short and sweet because we don't do a lot in 6.2. We do just a couple of things. The first thing that we do is what is called the dot product, which is just a way to represent a vector. It is also known as the inner product. The way we find the dot product of u, we'll let u be u1, u2, and v be v1, v2. The dot product, or u times v, is going to be u1, v1 plus u2, v2. So you multiply the components and then you add their products. So, quick example of that would be, what if we had 3, 4 times 5, 2. That would be 15 plus 8, or 23. You try 1, negative 2 times negative 4, 3. Pause the video, try it real quick, unpause the video, and check your answer. Right, you should have gotten negative 4 plus negative 6, or negative 10. Remember, vectors can be written in component form. It could be written in a linear combination, or you could be given ordered pairs and asked to find the dot product. Things that you should know about the dot product are they have lots of properties. It is commutative, which means u times v is still v times u. U times u would be the magnitude squared. 0 times u is still 0, it would be the 0 vector. The dot product is associative over addition and multiplication, which means you could add vectors and multiply the dot product, or you could distribute what you're going to multiply the dot product with, like if it is, for example, u times v plus w, you could find this and then do the dot product, or you could do the dot product and then add those numbers, or you could, that's it, sorry. With scalar multiplication, the dot product is also associative. Alright, you can use the dot product to find length, because whenever you are doing the dot product of just one component, it is u times itself, so it's u times u, which would end up giving you the magnitude. So it's kind of nifty. Alright, one of the things that is important in this section is the angle between two vectors. And the way we find that, it has its own little formula that we use. So the angle in between is found by cosine of theta is the dot product over the product of the magnitudes. Okay, so dot product over the product of the magnitudes. And just like before, that means we are going to say that theta is the cosine inverse of this. Okay, we typically use degrees with this as before. And let's do an example. If u is 2, 3 and v is negative 2, 5. I want to know the angle in between these. So basically what that's meaning is on a coordinate plane, 2, 3 is kind of right here, right? Negative 2, 5 is right here. I want to know what this angle is. That's what it's asking you. That's all. So that would mean theta is the cosine inverse of the dot product over the magnitude product. So I got to find all these. So your dot product would be negative 4 plus 15, or 11. The magnitude of u is the square root of 4 plus 9, which is the square root of 13. The magnitude of v is the square root of 4 plus 25, or the square root of 29. So when we plug these three components in, theta is going to be the cosine inverse of 11 over the square root of 13 times the square root of 29. This obviously you would have a calculator for because you don't know the cosine inverse of this quotient. It is about 55.5 degrees. Okay? Now, you try for u being 2, 1 and v being -1, -3. Take a moment, pause this video, work it out, unpause the video, and see if you are correct. Is -2 plus -3, which is -5. And then the magnitude of u would be the square root of 5. The magnitude of v would be the square root of 10. So theta is the cosine inverse, -5 over the square root of 5, square root of 10. But you can do the square root of 50 if you want to go ahead and multiply that out. Or you can just type it in. That gives you 135. How interesting is that? Alright, then next and the last thing in this section, even though there's a bunch of other things in the section about work that are kind of neat if you want to look into it, projecting one vector onto another, kind of some cool stuff dealing with some physics. But the last thing is vectors u and v are called orthogonal if u times v is 0. Meaning, if their dot product is 0, they are perpendicular. Orthogonal means perpendicular. Okay? Another way to figure this out, remember, u can be AB, v will let be CD, just to have a different number. If you remember how these were found from ordered pairs originally, using the heads minus tails rule, it's x2 minus x1, y2 minus y1. So if we write b over a, that's really our slope of u, right? And if we write d over c, that is our slope of v. So you can also compare them this way by looking at the fractions and using your traditional methods of determining whether something is parallel, perpendicular, or neither. Here, if they're parallel, then they're going to be the same fraction. If they're perpendicular, then they would be opposite reciprocals. Neither, two totally different things. Unfortunately, only the dot product being 0 will tell us that it is perpendicular. There's no dot product combination that would tell us that they're parallel. This is the end of section 6.2. What you need to be able to do before Monday is on page 472. Numbers 1 to 24. On Monday, I will check these, go over these from 6.1 and 6.2. Any questions that you have, we will go over. Then we will do 6.3, which is on parametric equations. We've done parametric equations before in chapter 1. That's the T equations. So we're going to bring those back up and talk about how they relate to vectors and kind of combine them with the cosine and sine and trig stuff and kind of put it all together. Your quiz is on Tuesday, so make sure you're really good with 6.1 and 6.2 or have specific questions about them coming into Monday so that we can answer them and then get through 6.3 so that you can be prepared on Tuesday. As always, if you have any questions, please, please, please text me over the weekend and get help.